So in this video, we have to learn the pin diagram of our 8255 PPI. So before going to start the descriptions, I will give you the techniques of how to draw this pin diagram. So whenever the diagram comes, the one question is going to our mind that how we can draw this diagram in our exam in simple manner. The answer is, first of all, you have to remember some key points. So what points you have to remember? The first one is how many pins are there. So total there are 40 pins. Then the second one is for 8255 how many ports are there. So there are 3 ports. That is port A, B and C. Then the third question is how many pins are there in each port. So total 8 pins are there in each port. So it will become total 24 pins. Now the second part is, now we have drawn with our port A, B and C. Now we will move to the read and write signal. So each and every IC is having the read and write signal. Then each and every microprocessor is having the address bus and data bus. So in case of 8255 architecture, it consists of 2 pins in our address bus, that is A0 and A1. And now in case of data bus, we have 8 bit of data bus, that is D0 to D8. And the last one, we also have this chip select signal and our reset signal. One more point is there, the ground and VCC connection is available in each and every pin of our IC. So whenever you remember these total 10 points, then it's easy to draw the pin diagram in our exam. So the first one is, we have to write down all the ports. So how we can write this port? First we start from port A. So this port A will be starting from this pin number 4. Then we have to give this in the right direction, that is 4, 3, 2, 1. This is the reverse direction we have to follow. That is port A, 0, then this is 1, then 2 and then 3. Now we have to go with that pin number 40 and again in reverse direction, that is 4, 5, 6, 7. Now you can check here. This is our port B, that is 0, then 1, then 2, then 3, 4 and 5. Next one is, we have to draw here the port C. So port C lower part will be there in that pin number 14 to pin number 17. And the next part, that is upper part, will be there from PC4 to PC7 from our pin number 13, then 12, 11 and 10 in the reverse direction. So now there are 2 address lines are available, that is A0 and A1, and that are given in our pin number 8 and pin number 9. Total there are 8 bit of data bus will be there, that is D0 to D7. Each and every pin is having the ground and VCC connection that we have drawn here, the pin number 7 and pin number 26. Read and write signal is also available in each and every pin. So we have drawn here in pin number 5 and pin number 36. Then we have to write here the reset signal and the chip select signal. So in that way, you can draw your pin diagram for our 8255 microprocessor. In this video, we will learn the pin diagram of our 8255 PPI, that is Programmable Peripheral Interface. In the previous video, we have learned the functions of 8255 microprocessor. So in our 8255 processor, which consists of total 24 pins, and it consists of total 3 ports. So here port A, port B and port C. These are the 3 ports are available in our 8255 microprocessor, and each and every port is having total 8 pins in each and every port. So 3 into 8, that is 24. So that's why 24 pins are available in our 8255 microprocessor. So whenever we are considering this port A, we can write it as it is, that is PA0 to PA7. This port B can be considered as it is, that is PB0 to PB7. The ground and VCC connections are available in each and every pin of our microprocessor. So VCC and ground connections are there in our 8255 processor, and here you can check this PC will be divided it into 2 parts. So there are 2 parts are there in our PC0 to PC7. The first part is PC0 to PC3. So this part is considered as a lower part, and the PC4 to PC7, this part is considered as the upper part. So lower and upper, these are the 2 parts are there in our port C 8-pin architecture. So you can consider here in this diagram, this port A and port C of our upper part will be considered in our group number A, and the port C lower part and port B will be considered in our group B. So this is our group A and this is our group B. So there are 2 groups are available in our 8255 processor architecture. So this is the concept of our port structure. Now you can consider the pins that are given in the left side. The first pin is D0 to D7. So D0 to D7, this is our 8-bit data bus, and that is used for transferring the data. So whenever we are considering the features of our 8255, we can write it as 8255 consists of 8 bit of data bus. So these pins are considered as D0 to D7. The first structure is our port number. Then the second point is we have total 8 bit of data bus. Now there is a reset signal for clearing our input as well as our output. Now the next pin is RD bar and WR bar. So RD bar is used for reading our input signal, and WR bar is used for write our data as an input signal. So bar is there in our RD and WR pin. That means these pins are considered as a low signal. So whenever your processor is in low state, that time this read and write pins will be activated, and whenever it is activated, your processor is ready to working the operation for reading and writing the data. Now the chip select signal is there, and that is also low signal. So it is used for selecting your address lines. So these are the 2 address lines are available in our 8255 processor. So there are 2 address lines are there that we are considering here in our 8255 PPI are A0 and A1. This is called as an address pin. So here these 2 address pins are available, and we have this chip select signal, that is CS bar. That is called as a chip select, and this is our low signal. So whenever we are considering this truth table for our selection of the port, that time we are considering here this port 0 and 0 for port A. This line of selection is 0 and 1 for port B, and if it is 1 and 0, this is for port C, and if it is 1 and 1, then control register will be activated. This is the low signal. That time we are considering this all signal as 0. So how we can decide this 0, 0, 0, 1, 1, 0 and 1, 1? Because we have 2 address lines, that is A0 and A1. So 2 raised to 2 is nothing but 4. So we have total 4 cases in our selection of port A, port B and port C. So as per our truth table, we are writing these four cases as 0, 0, 0, 1, 1, 0, and 1, 1. So these four cases will be there. If it is 0, 0, then port A will be selected. If it is 0, 1, then port B will be selected. If it is 1, 0, then port C will be selected. And if it is 1, 1, then control registers will be available in our 8255 architecture. So this is the diagram for your 8255 pin diagram for our 8255 processor, and here you can check that if we are selecting the port A, then address is 80H. If it is port B, then we are considering the address is 81H. If it is port B, then we are considering this address as 82H, and if it is a control register, then we are considering the address is 83H. If your chip select signal is high, that times it is selected to 1 and there are no signals will be there for our address lines, that is A0 and A1 will be in a toggle case, and there are no signals will be selected, that is a no selection, and no address will be defined for this signal when our chip select signal goes to high. If it is a low, then your ports will be active. If it is a high, then your port will not be active. So now consider here in this pin diagram, this will be there in our port pin number 8 and pin number 9. Each and every pin IC is having the ground connection and the VCC connection that is given in that pin number 7 and pin number 26. So see here, the chip select signal is there in pin number 6, that is used for selecting our address lines. Then port A consists of total 8 pins. So how we are writing these 8 pins are there in our processor architecture? Here we are writing PA0 to PA3, then this is your PA4 to PA7. So port A will be completed. Now you can check here, we are writing here PB0, PB1, PB2, then this is 3, 4, 5, 6 and 7. So our port B is also completed. Now we have to write our port C. So this is your port C, C0, then C1, C2 and C3. Now our port C is divided into two parts. So that's why we are written here PC4, PC5, PC6 and PC7. Now what is remaining? Our data lines are remaining that are given in that pin number 34 to pin number 27. So we can consider here pin number 27 onwards to till pin number 34. We are writing it as 34 pin number is our pin number D0 and this is your pin number D7 that is written in that pin number 27. So these are the 7 bidirectional lines are there. That's why this symbol is written in our data signal. And these ports are also bidirectional, so that we are writing this bidirectional symbol in our port A, port B, and as well as our port C. So now there is reset signal is available for resetting our input. RD bar and WR signal that is used for reading and our writing of our data. So in this video we have learned what is the pin diagram architecture for our 8255 PPI, what are the functions of pin, how we can select the address lines and how ports will be selected based on that address lines.